Okay, this is part two of proof Pythagorean theorem. Okay, so what we're going to do now is we should all have the intersection point here. We're going to create one more circle using the compass tool. So we have the compass tool. We're going to select point C and point A. Oh, we already have the circle here. Okay, so we're going to put that on point F. Okay, and use your intersect tool to create an intersection point between the two circles that pass through point C with center at point E and A and F. And now we can create our second square. So we can use the polygon tool to create our second square. And then of course we want to change the color of that square also. Make sure you're in the move menu and select the square, and I'm going to change it to, let's say, pink and 30 as the contrast. 35. Okay, that's fine. Okay, we're gonna make this a little smaller by zooming out a little. We're gonna move it because our largest square is on the bottom. So if you take point C and move it around, your square should change. Your square should change if you move point C around. Your square should change. Okay. Now, select, if you hold the control key down and select the three circles and the perpendicular line, you could see on the right, over here that they're highlighted. So I'm going to turn those off. See how they're highlighted? Okay. And so now we just have the two squares. Okay. So now let's do our final square on the hypotenuse side. We're going to create a perpendicular line that passes through point B and is perpendicular to F. Okay, so perpendicular line that passes through point B and is perpendicular to line F, line segment F. Now we're going to use our compass tool, and we're going to use the compass tool 3 times. Select point A, select point B. We have a circle with radius, line segment AB. We're going to put that on center on point B. We're going to use the intersect tool to intersect the perpendicular line that we just constructed and the circle we just constructed using the compass tool. And that's point H, to construct point H. We use the compass tool 2 more times. Compass tool, select point A, select point B. Let's put the center of this first circle at point H. Select point A, select point B. Using the compass tool, we should have a circle with radius, line segment AB, and we're going to put that center of that circle on point A. You can see the football shape here, or the fishtail when we did the construction with compass and straight edge. We're going to use the intersect tool to intersect the two circles we just constructed. That would be point I. And then finally use the polygon tool to construct your final square. The square on the hypotenuse side. We're going to change the color of the square on the hypotenuse side, select it, and we're going to change that color also. I'm going to change it to gray, and the contrast will be a little at 30. Okay, our final, we could zoom in, we could zoom out a little so we could see the entire, we could leave the circles here. The final thing that we need to do is find out what's the area of these squares. So in class, we divided the squares into square centimeters. Let's go to the measurement tool, select area. Select area, and you're just going to select the 3 squares. 1, 2, 3. Go to the move tool, and now you can see you have a dynamic proof of the Pythagorean theorem as opposed to our single particular instance that we use compass and straight edge. And now you could see you've created hundreds, if not thousands of different right triangles. And if you add the areas up, I mean, you could just visually see that the square, when the small square is close to 0, the big square is equal to the hypotenuse. When they're the same, 25 plus 20 is about 44.89. So here, this is a dynamic proof of the Pythagorean theorem for many, many different right triangles. And you can also increase the size of the triangle, I believe, by point B. So you can increase the size of the triangle, make the size of the triangle smaller, and then you can create different angle right triangles by moving point C. And so therefore you have a dynamic proof of geometric proof of the Pythagorean theorem.